Good evening to everybody. Once again, I welcome you all to another beautiful presentation on this control system subject. And since long, we have studying, seeing about the basic concepts of control system, especially the topic which we are studying and observing is the basic step or the initial building block of this control system subject, in which we have started with the different types of control systems, means closed loop system as well as open loop system. And then with respect to the closed loop and then open loop, we have seen some examples also that can be reduced with the help of block diagram reduction rules in order to find out the transfer function of given block diagram. As well as after that, we have gone for the second second method of finding the transfer function uh, of the same block diagram, and that can be converted into signal flow graph. And with the help of the signal flow graph diagram, we have seen a few examples on how to find out the transfer function. So I think you are enjoying these presentations, and definitely you will I can definitely assume, and I feel that you are enjoying. So in today's presentation also, I am going to explain you another important question, and which is normally many times which is asked in academic examinations, and you can expect this question in your IAS examination also. As I have explained in previous session, in IAS examination, you have descriptive type questions also. There you can write in steps or theoretical questions also there. So today we'll start our presentation with, that is the lecture number 15. It is lecture number 15. So in which I am going to solve for you another important question that has been asked for many times in academic examinations. So quickly we see that in today's presentation. So there is a block diagram is given. Actually, there is a block diagram is given, and for that block diagram, you need to find out the transfer function. Let us see. I will explain you that. So for that, you have one summary here. It is given like this. You have one summary. After that, you have gain 1. After that, you have summer. And after that, you have gain 2. Okay. And after that, you have one more summer, summing point or summer point. Okay. And after that, you have one more summer again. And after that, you have G3, that is gain G3. And after that, you have your C of S. This is your output C of S. And here it is given like this. This is symbol plus, and it is given as minus. This is plus and this is minus. And for this, it is given with negative feedback. Actually, this arrow mark is going to negative sign. Then this is called as a negative feedback. And the gain of this is H1, means H1 is the gain of this feedback, and it is coming from here, from output. Okay, this is coming like this. As it is coming reaching to in reverse direction, then the same arrow mark can also be represented here, so that to avoid the confusion. And then after G3, okay, so here before this summer, for this you have one more feedback loop is coming, that is the loop gain is as H2, and it is coming to minus again. Here it is going to minus. Remember that the minus can be identified in summer itself, or otherwise it can also be represented nearer to the arrow mark. Here it can also be identified, can be represented minus sign, is it not? And this H2 is directly is shown here, means the connection is shown like this. Okay, arrow mark you can represent like that. And then you have after G2 there is a summer here. In fact, you see this, you can identify this as plus, this as plus by default. Actually this is plus because it represents the input signal going in forward direction. And after G2 you have one summer point. Between these two summer points there is a takeoff point from where you have one feedback loop with gain. What is the gain? It is H3, the feedback loop gain. It is coming to this summer point here. Arrow mark is coming. Okay, the symbol is minus. Okay, this is the given problem. Not only that, here in this problem it is given that here one arrow mark has given, and it is station 1. This is station 1. And similarly here one more arrow mark has been given. This it is given in problem that it is station 2. It is station 2. This is the problem given. This is the given problem. So there is a H1, there is a H1, and then H2, and then H3 is there. Okay, and then this is called station 1, this is called station 2. So in this problem it is given that evaluate, the question is this, evaluate the closed loop. What? Evaluate the closed loop transfer function. Closed loop transfer function. Transfer function when the input R of S is first point at station 1, at station 1, and second at station 2. This is the question. You are asking that. This is the given question. In this question, evaluate the closed loop transfer function, nothing but the overall transfer function, nothing but your C of S by R of S. Here R of S is not directly shown in this. Instead of showing that R of S, it is given that station 1 and then station 2. Now in the first condition, it is given that assume that your input R of S is at station 1. means that at station 1 you have to consider that R of s is there, like that you imagine. So means that instead of station 1 you just write R of s here for solving point number 1. Okay, first bit otherwise. So you assume that R of s is there here, R of s is there. Okay, then why, for solving the first point or first bit, this one, the station 2 must be put to 0. Station 2 must be put to 0. Then only you can obtain C of s by R of s. So that is what we have to do. This is the given question. Now we will solve. So of course this we are going to solve with the block diagram reduction only. So we are not at all applying the signal flow graph method for this. Okay, because it is not asked like that. It is given. So for this given problem, using block diagram reduction only can be easily solved for this. This is very simple problem actually. In fact, if you follow this, if you follow my presentation, definitely will enjoy this. Definitely. So the first condition is considering that your R of is at station 1. Okay, considering your R of s is at station 1. If you consider that condition, then what you need to do, you put this station 2 as 0. That means that completely you have to remove this. Completely you remove this from the diagram. This summer point will be terminated, or it will be just removed. Then directly you have connection, direct connection you have to show. That's all. Okay, then this is your R of s, then it becomes your R of s, and remaining we will see how it is to be evaluated. That is first condition, we have to solve like that. And coming to the second step, that is in second point at station 2, imagine that your input R of s is at station 2. Now your input R of s is at station 2. In this case you put to 0 this summer point, means you have to remove this summer point. You have to remove this summer point because station 1 is to be put 0, means the summer point is to be simply removed. Then what about this connection? Nothing okay, so this connection is directly connected to G1. That's all. Means this connection is directly connected to G1. And one important thing you need to remember is that, see this feedback whichever is coming to this summer after H1, this H1 is going to which sign? Minus sign. Therefore you have to connect this arrow mark to this G1. You just put this minus before H1, means this minus is applicable to H1 only, na? That's why. So H1 comes in series with G1. If you remove this, then H1 G1 will be multiplied. Then this will become a product, H1 into G1. Then before that you just put the minus sign. The minus sign. Okay, minus sign means minus G1 H1 will come. For that case, actually I am explaining. Now let us solve the step number 1, means point number 1. Assume that your input is at R of station 1. Okay, then what we have to do for this? Let us solve that. I am erasing this question. Let us solve. What will be the answer and how it can be solved? Let us see. So as I have explained just now, assume that at station 1 you have your input, means you have your R of s. Solution. Now see the solution. Solution for step, I mean first point. Solution for point number 1. It is for point number 1. Okay. Then at station 1, we are assuming that R of s is there here. You have your R of s here at station 1. Then in this case, so I will try to minimize in the diagrams itself instead of writing so many blocks. So I will explain you how the blocks will be minimized, will be reduced in order to get that C of S by R of S. Okay. So assume that R of S is at station 1. By assuming this, what we have to do? We have to put this as 0. This will put to 0. This we have to remove, because we are considering station 1, then definitely station 2 is not to be considered, means it has to be removed, means assume that it. So then what we should do? Completely you just remove that, that's all. It should not be there. It should not be no station 2 for the first condition. Only we are considering station number 1 only. Therefore you don't have that, you do not have that directly. You just show this connection like this. That's all. That's all. That is the question. That is your equivalent. You have to remove this point there, summer point. Now see, it is easy now. What we have to do now? How to solve this? How to minimize these blocks? So here, as I have explained in our earlier sessions, I think if you might have remembered that, always let us see, we have to, so what are the loops, what are the feedback loops available in the signal flow, I mean in the block diagram you have to see. So here this is one loop is their feedback loop, this is external loop, you can say this is the external loop. Then what are the interior loops? So interior loops means again from here to H2 is coming to here negative, means from here, from the summer there is a gain and it is like a loop, is it not? This is a loop, but in this there is a takeoff point, so that takeoff point should not be there. This takeoff point should not be there. In order to simplify this loop, understood? In order to simplify this particular loop, there is a loop here, there is a this is one loop basically. So in order to simplify this loop, this takeoff point should not be here. What can be done for this? You simply can shift this takeoff point to after G3. You can shift this takeoff point after G3. Then if you shift this connection which is there before G3, if you connect, if you disconnect from here and if you shift this connection to after G3, what will come? Have you remembered that? So in this path, there is a small amount of gain will be added. I have told you in the previous presentations, in classes otherwise. When you shift this takeoff point after the block, as per the one of the important rule of this block diagram reduction, if you shift this takeoff point which is there before the block, if you shift this after the block, there is some gain will be added to this path. What is the gain? That is 1 by G3. What is that? 1 by G3. This much gain will be added in this path, and now this can be connected here. Means what I am going to do with that? Now you can just disconnect this connection here. Following? You just disconnect this connection here. Let it be this. You can okay. You can represent this loop, no problem. Now this will be connected. This will be connected to this one, this block, and this will be connected to, I mean, outside. Means what? Means what? H3 here, if you see, H3 became in cascade with 1 by G3. Okay? Therefore, now I will explain you forever this thing again. Because all red, blue are there, no? You may feel a little bit. Nothing to confuse here. Nothing. I am not at all doing any new thing here. Just I am applying the rule and just I am trying to minimize. So here, what is the, again red pen. here, what is the gain? 1 by G3. This you can show somewhere after G3, no problem. Okay, so means that what? By doing this, now H3 and 1 by G3 will be multiplied here. Therefore, in next step, what you will do? What we can do? Simply these two will be minimized and these individual blocks are there. No, this is one block, this is one block. So you can represent as a single block H3 into 1 by G3. Therefore, H3 by G3. That's all. You can, instead of writing two blocks in the, actually this can be represented in the second step, but in a simple, in only one block I am going to explain all these things so that this is whatever H3 by G3. Is it not? H3 by G3. Then what can be done now? What can be done now? Now carefully see this problem here. Now this is what your loop, one loop. Now you can easily simplify this loop, and here I can rearrange this diagram. So I can show this connection, whatever the connection is there here, I can show this connection separately like this also. Means that I can disconnect this connection here, and you can show this connection like this also. You can show like this also. Nothing wrong in that. Understood? So actually this is what given in the problem, but you can disconnect there and you can connect this to direct to CS also. Nothing wrong in that. Now what can be done here? Now the interior loop, this loop can be simplified first. Means this is a closed loop control system with negative feedback. So this is the closed loop control system with negative feedback. What is the gain? G3, and this is feedback gain H2. So for the negative feedback, how it can be? What is the resultant? So if you reduce this loop, for this loop, okay, for this marked loop, for this marked loop, what is that? That can be given as, okay, G3 by, I will write here for you. It is given G3 by 1 plus G3 into H2. This is what the equivalent. If you minimize, if you reduce that, if you simplify this entire with the help of that one of the rule, means eliminating of negative feedback loop. The rule is nothing but elimination of negative, because it is negative sign is there. That is, it is called feedback is coming to negative sign. That is called, this is called a closed loop control system with negative feedback. Means this negative feedback loop shall be eliminated. If you eliminate that, what is the resultant then? This is the resultant. Gain by 1 plus gain into feedback element. That is G3 by 1 plus G3 into H2. Then what I will do here? So I will remove all these things. I will remove, and simply I can put okay. Here what I will do? Just one block will be added. This is however like this. What is that? Actually it is G3 by 1 plus G3 into H2. That is after elimination of that negative feedback loop which is available there. Is it not? So in your textbook you can write in different steps also, no problem. So I am explaining you within the problem itself. Okay, if you follow this, definitely it will be understood. So I have eliminated that negative feedback control system. Then it will be simplified like this. Now again, if you see, now this entire block is in series with G2. and these two will be in cascade. Therefore G2 and this product G2 is to be multiplied with this total. Therefore what is the resultant? G2 into G3. Therefore what is my, then you can remove this G2, you can remove this G2, and you can have a direct connection to this block, and you can write G2 G3 here. It is G2 into G3 because this G2 comes in series with this, therefore both will be multiplied. Therefore now here G2 into G3 by 1 plus G3 into H2. So this is your block now. Okay, it is simplified like this. And again, see carefully, again what can be done here? Now here again you can observe this is as a loop, this is the second closed loop. This entire, this one, means one, this one I am going to see you actually. So this one, if you see this, again it is a gain, but the feedback is shown just above the block. It can be shown below the block, above the block, nothing to worry, because you just focus on the how the feedback is coming, where the feedback is to be connected. Is it plus sign or negative sign? It is going to negative sign. Therefore again it is a negative feedback loop. Then this loop is also to be eliminated. Now you have to eliminate this. You have to eliminate this. So for elimination of that, this is the gain, this is the feedback. Then gain by 1 plus, what is the formula? Gain by, if you eliminate that negative feedback, gain by, it is gain by 1 plus gain into feedback. That is what for a negative feedback, with negative feedback. This is the formula. Gain by gain, your gain is nothing but this entire as gain. You have to consider this entire product as G, and again 1 plus G. G is nothing but same as this. And what is your H? H is nothing but here. H3 by G3 is nothing but your H. So simplify and substitute G and H in this formula, in this rule. Already this is one of the rule, you know, already explained in the earlier sessions. Then I will simplify here. Then the resultant will be, I will note down there. So what is the then gain by, means it is G2 G3 by 1 plus G3 H2. This is what your gain actually, is it not? This is what your gain by 1 plus gain into H. Gain means again this entire you have to write, it is G2 G3 by 1 plus G3 H2. This is gain into feedback, H3 by G3 into H3 by, you have G3. This is what this is equal to, is it not? If you carefully see this, okay, so 1 plus this gain into feedback. Then if you see here in denominator G3 is there, numerator G3 is there, both will be cancelled out here because this is multiplied by with this only, is it not? 1 plus G into H. Therefore G into H. So G3 will be cancelled out. Then what will remain? G2 into H3 will be there. G2 into H3. Therefore, so you can remove this G3 from here to here, and you can just write your H3 here. Means you have G2 into H3. Now you further simplify this. Further, this is equal to this one. If you simplify this product, what will you have? In numerator, you have same G2, G3 by 1 plus G3 into H2. This is your numerator. Coming to denominator, this one. If you simplify this denominator part, 1 plus G2H3 by 1 plus G3H2 means whatever product is there in denominator here, I mean if you consider this much, this is your numerator, this denominator. This denominator part 1 plus G3H3 is multiplied by with this one. If you take this one as your okay, cross multiplication, this entire will be multiplied by this plus this by this will come, means 1 plus if you multiply this entire will be multiplied by here 1 plus G3H2 into 1, nothing but the same will come here, means 1 plus G3H2 1 plus G3H2 plus G2 into H3, is it not, by what will come, this one 1 plus G3H2 means 1 plus G3H2, is it not? This means this means 1 plus G3H2, this 1 plus G3H2 will be cancelled out, is it not? Both will, this further can be written as G2 G3 by G2 G3 by this one, what is that, 1 plus G3H2, is it not, G3H2 plus G2H3, that's all, because these two gets cancelled already. Therefore G2 G3 by 1 plus G3H2 plus G2H3, this is what your resultant. If you eliminate this feedback loop, if you eliminate this total block which is identified within the red marking, then you will have this answer. Therefore what I will do here now, just I will remove the entire block here, this completely, all this I will remove, okay, all this can be removed, and you can remove this red mark also, not required now, okay, no red mark is required, okay. Then what I will do here, you just draw one block, and this is your output entire, this is not at all there now, simply you have your output connection here, this one, okay. What will be there in this box, G2 G3 by the same whatever you derived here, that much quantity you write here, 1 plus G3H2 plus G2H3, understood? So now that is what your equivalent, I mean gain after eliminating that loop. Now what you can see, now this G1 became in series with this one, now both these two are in cascade, then G1 is multiplied with this total, then obviously our G1 comes here, therefore I can write G1 here, okay. I remove G1 here, then if I write G1 there, so you should not represent again here because it is already in cascade, therefore it will be like this, understood? So I think let us see what we are doing by this way. We are reducing the number of blocks, understood? We are reducing the number of blocks. Now almost all we reach to the final. This is the final step now. Now the answer is going to be obtained in very short period. Now see that this is your R of S, this is your gain now, this is your gain, this is your output, part of the output given with the negative feedback with gain H1. Now this, consider this entire as your H, I mean gain G, and this is your H, again with negative feedback, this is your R of S. Then finally what will be the answer? What will be the answer? The finally you can see that, so this is gain by, what is the thing? This is again negative feedback, nothing but gain by 1 plus gain into h. This is what your C of s by R of s. This is what your, so here gain is equal to this entire part, and h is nothing but h1 only. Therefore I can erase this, and finally I can simplify, and you can just keep as it is this quantity for simplification. Okay, and final step, actually this is final, this is gain. Let us see, this is entire as gain, means I am going to find out your transfer function. This is almost all your final step. C of s by R of s is equal to, this is your gain by 1 plus gain means again the same, it is g1 g2 g3 by the same 1 plus g3 h2 plus g2 h3. This is your gain. What is the feedback gain? h1. It is h1, is it not? H is nothing but h1. Now if you simplify that, so it gives your answer. Okay, then what will be done here? This implies furtherly what we can do. So this h1 comes here, obviously, is it not? Product only, no? Therefore that h1 you can simply identify, indicate there, h1 already. Now as we have seen, so here denominator, this entire thing will be come here, it will be multiplied with 1, then here what will come? 1 plus the same, the entire will come here, 1 plus g3 h2 g2 h3, everything will come here in place of 1 plus this one by 1 plus g3 h2 g3. It will come like that, is it not? So means that what? If you simplify this, what you will get? 1 plus, otherwise I can write for you. Okay, I can write for you. I can simplify this as this as 1 plus G3H2 plus G2H3 plus what is that? G1, G2, G3, H1 no? By 1 plus G3H2 plus G2H3. Is it not? The same will come denominator. Then these two will be cancelled out. Is it not? Same, no? 1 plus G3H2 plus G2H3. 1 plus G3H2, G2H3. Same. So these two will be cancelled out. Then what is your final answer? What is your final answer? G1, G2, G3 by what remains? What remains? G1, G2, G3 by this one. This one. Okay. So I will write here. Otherwise, I can. Okay. Like this. G1, G2. It is your transfer function is nothing but G1, G2, G3 by this one. This is what your C of S by R of S is equal to this much. This is what your answer. This is what your answer. Very, very important question actually. So this is by considering the input R of S is at station 1. And let us try on yourself that consider the input R of S is now at station 2. Let us try on your own, and definitely I will solve this in the next session, because I would like to conclude today's session at this junction, and in a subsequent section presentation I will solve that. Okay, just meanwhile you try on your own that just you imagine that RFS is connected to at station number 2. Then for that case what you need to do, you have to you have to remove this station 1, you eliminate this, you put it to 0. Then let us see what will be answer. Okay, what will be the answer. So with this I am going to conclude this presentation, and we will continue in the subsequent one. So thank you one and all.